Hola clase. Today we are going to learn to work with similar triangles. And as usual, I'm going to give you a step-by-step guide on how to do it, and then we'll do an example together. Now, similar triangles are those that they may not be in the same position, but have the same angles, the values of the angles. That means that basically one is a zoom in or out of the other, or mathematically that the ratios, the proportions between the sides are going to be constant. That's going to be a very useful thing because it allows me to actually find missing sides, lengths of the sides. Of course, the problem is going to be to realize of that, but the how-to is actually quite straightforward. Now for the how-to, first of all, you're going to have to find the missing side in your diagram. Where is it? Once you've got it, you want to match it with an equivalent side in another triangle. And for that, you know the value. It's something that they either give you or you can get. Then you're going to have to find a pair of sides that are equivalent in both triangles and for which you know the values. After you've got that, you're going to create your ratio. And once you've got it, you can solve from there. Right, now let's see that in an example. They asked me to find the x, and this is what they give me. Okay, the first step is identifying similar triangles. Now in this case, because I've got the angles matching with symbols, they're telling me that they actually the same value, even if they're not giving me which is that value. So I know that the angles are all equivalent in both triangles. Then I need to find the x. I need to identify what do I want. So I think about that, and I've got it there, which is a good thing. Then I need to figure out if I know the equivalent size. If not, I'm going to have to find it. The equivalent side is going to be the one in between the two angles that are the same. So I come in here, it's this one here, so I've got it. And then I figure out that I need a pair of equivalent sides. Two sides of which I've got the values. In our case, are going to be this one here and this one there. So I'm going to name everything. Remember that when I'm naming a triangle, from any triangle, the angles always go in capital letters and the sides are matching but with lower cases. So I'm going to name everything. So this side that I know, it's going to be lowercase a. This is the one that looks at the C, and this one for which we don't know anything, it's going to be a B. In this other triangle, the x is already given to me. This is going to be lowercase y. This is going to be a lowercase z. Now this is important because I need to put everything correctly when I am creating the ratio. So remember that the proportion between matching sides is a constant. So sides in between the same two angles in both triangles, the ratio is constant. The way of remembering where to put things, you go both through numerator or denominator. They need to be values about the same triangle, and then in each one of the ratios there are sides between the same angles. That way you know you've got the right one. All right, I've got everything. So remember, all of that happens in my brain. Green is what I think. So I'm ready to put things in here. Now I'm going to put the x in the numerator because it's easy. Then I need to put the denominator of the side that matches. In our case, is an 8. That's equal to the ratio of two sides that we know. Important, x is in this bigger triangle, which means that in the numerator goes the 32, and the 8 is going to match with the 20 according to this rule of same triangle. Now from here, it's a matter of simply eliminating there. If it's dividing, passes to the other side, multiplying. And now these are numbers and operations, which means I can get a value. So I come here, and in our case, 12.8 centimeters, because we had units. So now we've got the side that was required. We box it so it's easy to find, and we're done. Now it's your turn to go and practice. Thanks for watching.